Hello everyone, I'm Bryce with Stream Systems, and today I'll be walking you through a use case demonstration in SimOpti. So as you can see, we're starting with this network configuration that I've modeled in our SimOpti canvas. To further explain it, let's head over to the standalone engine. So as you can see from this network configuration that we've built, there are two pipelines, each feeding in an emulsion blend to this initial separator that removes a significant portion of the gas and water from the emulsion blend, which carries through to this splitter that divides the emulsion blend into two trains, consisting each of a separator unit, a treater, a tank, and a pump that continues on to the marketplace client. There is also a feeder that injects a feeder emulsion that blends with the original emulsion blend from the pipelines, consisting of only water and oil. The water removed from all of the separators and treaters are collected in this lower line to be stored in this tank, which is then distributed to the water treatment facility. The gas removed from all the separators and treaters are collected in this line above to be split into these two outtakes. Both the pipeline and the feeder have weekly nomination batches that need to be injected into the network and received at the client end. The client has demands on a daily basis, hence the pipelines can inject large volumes into these tanks that the clients can withdraw from on a daily basis. So let's say that this network accurately represents a company's field operations, and we're trying to identify some of the inefficiencies in the network configuration. So if we speed up the simulation, So as we speed up the simulation, we can see that these separators at the beginning of the network seem to be bottlenecked by a certain constraint. And it looks like our water tank and the limit of flow to the water treatment facility is actually bottlenecking the system. So we have this simulation to run from January 1st, 2021 to the 2nd of April, 2021. So we can look at the Q1 performance of this network. So let's skip on ahead to the end of the simulation. And from here, what we can do is, by accessing our marketplace clients, we can go to the outflow directly and look at a throughput reporting log. And from here, we can see the volume of product that was received by each of the clients on a monthly basis. So by taking this information from both client 1 and client 2, we can store these values and try to improve upon them. So first, by looking at our system in action, the bottlenecks seem to occur in the initial major gas separator unit and these two primary water separation units. So if we were to install some sort of water outtake or well that would be able to offload some of the water, we may be able to increase our productivity to the client by alleviating the bottleneck in these separator units. By going to our canvas in SimOpti, we can easily reconfigure our network. So let's try out the idea of deleting this line and adding a splitter that will feed a water outflow. And let's just call this water outtake 1. And we can simply reconnect all of our lines. Straighten these lines out a little bit. And save our network. So if our water treatment facility has a flow rate limit of 270 barrels per hour, why don't we increase our total capacity for water transport by about 10%. So let's make our max rate for the water outtake a mere 30 barrels per hour. So now that we have our new configuration, let's run the simulation and see what happens. So now that we have our new water outtake and water splitter configured in the network, we can see that the water outtake is alleviating some of the bottlenecking that previously occurred within the network. And our nominations seem to be flowing a bit more smoothly to the outflows. Upon completion of the simulation, we can check our outflow volumes and by comparing the outflow volumes with the reconfiguration of the network, we can actually see that this reconfiguration is resulting in a 3.54% improvement in material delivery to the client. However, in an instance where maybe we don't have the ability to configure another water outtake anywhere along these lines, although we do have the ability to tweak our existing infrastructure and increase the capacity of the water treatment facility from 270 barrels per hour to 300. In order to do that, we would return to our canvas, where we can simply deactivate our water outtake and tweak our existing infrastructure so the limited rate on our water treatment intake is increased to 300 barrels per hour. So once we save our scenario and rerun the simulation, we can now see that the water outtake has been disabled, noted by the lime green color for inactivity, and our water treatment facility has increased its capacity of flow rate to 300 barrels per hour. And again, we can see that alleviation of the bottleneck is also occurring in this simulation as well. And if we fast forward to the end of our simulation, we can go to our outflow data at the client level, go to our throughput reporting log, and verify that yes, we are still improving upon our original configuration by 3.54%. So, in summary, with SimOpti's facility simulation, we were able to identify a bottleneck in the supply chain, experiment with different scenarios to find the right solution and alleviate the constraint, and with this new information, we can make a data-driven decision, either financially or operations-based, before the scenario becomes a reality. I hope the walkthrough of this use case has been helpful to you. If you have any questions, browse through the SimOpti tutorial playlist on the channel, or get in touch with us at info@streamsystems.ca and we'll help you out.